First, Bernard, I'd like to thank you for that talk. I thought that that was very instructive, and I think our talks fit nicely together. My talk is focused on the front end of the process. And as Bernard said, it always starts with basic research. And that is what the goal of the Audacious Goals Initiative is. Actually, it's to take that basic research and to move it enough forward in the pipeline thoughtfully in the academic community that we can have a handoff into the next stages of getting drugs to the market and to people. I like this. This is a statement from Francis Collins, and I think all of us in the room who are vision scientists see some wisdom here. When he said, it's often, it seems to me, that vision research is a couple of steps in front of things that are happening in biomedical research. It is clear that vision research has played a disproportionately large share in scientific breakthroughs. As I think about the talks over the last 2 days, there was deep science, there was understanding of disease, and there was presented an opportunity to move things from understanding the basic biology and to try these in people. Several years ago, I happened to just be doodling on a piece of paper and made the list that I'm sure many people in the room have made, that starting with the human genome sequence in 2001, very interesting things have come about. And a surprising number of these have the word vision written on them, such as in 2005, genetics of common complex disease. Now, that's a common thing to have risk genes for common complex disease. But in 2005, the complement factor H, CFH gene, was gene number 8. Not 10, not 100, not 1,000, not 5,000 the way we have now. It was gene number 8 to be understood as conveying risk of a common complex disease. iPS cells were rapidly turned around in 2011 and 12. Human gene therapy, we heard that this morning, RP65 replacement. A lot of the advances that have happened over the past decade have come out of the vision community. With those ideas in mind, the National Advisory Eye Council, which is the advisory group that handles the public affairs of the National Eye Institute, I discussed these ideas with the Advisory Eye Council and asked them what their idea would be on something truly remarkable to focus on and to commit some amount of the monies of the Eye Institute over the next decade and some. The way we went about that eventually was to put a challenge to the world, and 548 people responded with ideas. Those ideas then we took to a meeting of 200 attendees, and I see here in the audience a number of you who came to the meeting in Washington in February 2013. And over the course of 2 days, worked at discussing what would be truly remarkable. The outcome of that was this idea to regenerate neurons. Neurons, after all, are something quite vital to vision. The sense of vision depends on many elements of the eye and motility and perception, but much of it starts with photoreceptors and ganglion cells, as we heard yesterday and today. And so the idea of the Audacious Goals Initiative, the target, is summarized here as regenerating neurons and neural connections in the eye and the visual system. As we have also heard the last 2 days, saving photoreceptor cells or putting in new ones, but not paying attention or failing to connect those new photoreceptors into the visual system would not accomplish very much. So I'd like to tell you now just where we stand, we as a vision community, where we stand with the Audacious Goals initiative. Money has been put on the street, money on the order of millions of dollars. And the first amount of money was in 5 awards from May of 2015 for imaging, not for ordinary taking pictures, but to look at imaging as a tool to understand function. Ultimately, to know that the transplanted neurons are functioning is going to require tools and techniques that we currently do not have. So in May of 2015, we put money on the street in the form of about $4 million a year for up to 5 years to 5 groups. And again, some of the names on this list, particularly Chris Palczewski, is shown here. And when one looks at the titles and the topics of these awards, the idea of function is really embedded in each of the initiatives, each of the areas that is being worked on. Optophysiology, non-invasive in vivo monitoring of activity, and in the case of Chris Palczewski, not to pick on you, Chris, but all of us understand that retinoid metabolism is front and center. It's key to the function of photoreceptors, the retinal pigment epithelium, and vision. Now, not everything that I'm going to tell you here, I'm not going to lay claim that this initiative has moved the field so quickly, but embedded in the ideas of rhodopsin kinetics and retinoid cycling and imaging is, again, a paper that has Chris's name sprinkled across it. And this is that through autofluorescence and other techniques, one can measure activities that are related to photoreception, but in fact reflect retinoid cycling. And that will be very important at the time in the future, near future, when photoreceptor cells are transplanted, and we want to know in the patient, in the clinic, we want to know whether those cells are functioning. Retinoid metabolism is going to be a key to that. A second amount of money will be put out this summer. In fact, the National Advisory Eye Council is reviewing these 2 weeks from now. And we expect to award 4 to 6, to fund 4 to 6 awards at the amount of about 3 to 5 million per year for all cumulative or total for those 4 to 6 awards. And the topic on this is to look to identify factors that influence neural regeneration in the visual system. And again, we heard yesterday and today some of the ideas on how this might be done. Now, over the course of 2 years, beginning in November 2014, we have convened 4 meetings. We are calling them expert workshops. We've convened 4 meetings with chairs on the topics that are shown here: regeneration, regenerating the optic nerve, photoreceptor regeneration and integration, neural connectivity, and ganglion cell replacement. We've convened 4 workshops to gain a sense of where the field stands at the moment. And again, I would reflect that the ideas that we heard yesterday and today are a good representation of many of the ideas that have been discussed. Each of these groups was some 30 scientists getting together for a day, not to present formal talks, but to present the ideas, to argue about where the state of the field is and where it should go next in order to move this forward so that it can be taken from the basic research into the next steps, which ultimately will touch human and ultimately will be handed off, I expect, to ultimately commercialization. Just to go through those four very quickly, the ideas that came up at the first workshop on regenerating the optic nerve, which Jeff Goldberg helped to chair. He was a co-chair of that. Among the ideas discussed was, well, why can't humans regenerate retinal neurons? Because goldfish do it. How can we be more like goldfish? Or what is it about the goldfish, the biology that allows that to happen? And how does one identify the factors, presumably developmental factors, in human, which, when we manipulate them, can allow regeneration of retinal axons? How do we get new information about what those factors are? And then thinking ahead into the human context, how do we look at practical assays that can be taken into the clinic when we begin to test these factors in human? Now, that was a several-hour discussion, and obviously more ideas than this were covered. So for those of you interested, Jeff and Bill Guido have summarized what was discussed, and you can find this on the NEI website. The second workshop on photoreceptor regeneration and integration was held at ARVO last year, May 2015. And the outcomes of that asked about what are cell sources for photoreceptors. How do you deliver them? How do you get them to integrate? Again, assessment comes up because at the point that we actually take this beyond the mouse species and the non-human primate and we take it to the human species, but we are going to need to know how we monitor this in the clinic, in patients, in subjects. Very interesting discussion, and for those of you interested further in this, this report put together by Dave Gamm and Rachel Wong, who co-chaired that meeting, that is available. The third meeting on reconnecting neurons, this was, I think, particularly a fascinating meeting, and this should be available this summer in the Journal of Neuroscience. So I will leave it to you to have a look at that as opposed to reading this list. And then finally, the fourth meeting that was just held returned to the question of how do you replace retinal ganglion cells? And this also will be written up and made available to anyone who is interested. The ideas are starting to be repetitive now. How do you get integration? What are factors that would convert endogenous cells, latent, lurking endogenous cells, into active ganglion cells? What do you do about the fact that if you put in foreign cells, the immune system will be paying close attention to that? And we heard about inflammatory processes today in, among other things, gene therapy. So the common themes, there are many common themes, but among those, we need better research models. As I think Jeff said, optic nerve crush, there are many optic nerves that are crushed in the lab, and very few of those are crushed fortunately, in human. So it's a wonderful model for the laboratory, but to move beyond that into a context that anticipates human disease, we need different models. And instead of talking mostly about rescuing vision in mice, we need to be talking about models that recapitulate human disease in non-human primate or in higher mammal. Now, the way that we've gone about setting this up is not to hold all of this work within the National Eye Institute. Instead, I went to the vision community, starting with that meeting of 200 people, and asked their input. And along the way, throughout this process now, we have a steering committee. John Dowling is sitting here, Mark Blumenkrantz, many of you know, Josh Zanes, Pamela Raymond. This brings additional outside advice to the table to consider on thinking about where we are headed, what the trajectory is, and what's missing, and who or what type of person or scientist could be brought to the table to assist. And I thank these people because they have made a major difference in how we are approaching things. So that's the basic idea, that's the basic science, but we want to move beyond academic basic science. And ultimately, we want to be looking at human disease, ocular disease, and disease states. And so this year at ARVO, we convened a town hall meeting which was very well represented, big room and a second room, an overflow room. Len Levine moderated that, and Marty Friedlander, Joan Miller, Lois Smith, and Don Zach, Don is here, of course, had a discussion with the audience on the question of what diseases would you think about? How do you anticipate going forward? And it gets back to the optic nerve crush. Optic nerve crush is wonderful, but if basic science, basic discovery stops with the optic nerve crush, it is going to be a very hard transition into the human context. So among the ideas that were discussed were to identify characteristics of disease that affect photoreceptors, ganglion cells, and the characteristics that would make sense to think about treating with regenerative approaches. And when you would intervene, and how do you monitor the outcomes? These are questions that clinicians have insight into because they are the scientists who study the human species. So we need to have clinicians talking to vision scientists so that there is a handoff, so that the vision scientists, the discovery biologists are thinking forward into what comes next, and what comes next is human disease. So in 2 years, we have had really a busy time, and we have just passed this meeting, the town hall meeting on ocular diseases, and a meeting on experts on retinal ganglion cell replacement. And then in the fall at the Society for Neuroscience meeting, which this year will be in San Diego, we will take one more pass at looking at cellular environments, how you create the appropriate environment for neuroregeneration. And I think that the work that Chris Pelchevsky is doing to think about systems pharmacology begins to get into that zone very nicely. So the point here, what is the point of it? The point is that we are here at this meeting because we find the question interesting and important to think about how basic discovery research fits together with the human context. And we are also here because we are beginning in science to be a very collaborative discipline. These questions are big and broad and require many different tools. There are very few laboratories or even institutes that have all of the tools in one room or under one roof. And so part of the Audacious Goals initiative is to get collaborations among the various experts so that these fields can move forward better. Now, the scale of the AGI is just a part of what the National Eye Institute does. There are, in the United States, about 1,000 laboratories that are funded through the National Eye Institute. That funding will continue, but a part of it is going to be diverted into this effort, the AGI effort. But the vitality of science continues to be driven by the creativity of individual scientists, those 1,000 individual scientists. But we want to focus attention on regenerating neurons and connecting them. So along the way, there are a number of papers that will come out whether or not the AGI exists. We already heard yesterday from Shigang He, and we heard today from Jeff Goldberg. And it's because those are scientists who are interested in these questions. But as Bernard said, we really need to mobilize the number of experts. To have one person thinking about a problem and publishing one paper is excellent. To have 10 people doing that leverages the field and accelerates the discovery and the pace and opens up opportunities that otherwise would be missing. So I've come to the end of this, and I would just point to 4 things that you can do if you are interested further. And the first would be to consult the white papers that have come out of those expert workshops. 2 are on the street. The third one this summer, and the 4th one probably by the end of the year. The National Eye Institute website lists funding opportunities, and there are some that will be coming up right away. And then I would mention, as I already did, that the Audacious Goals Initiative is just part of the National Eye Institute funding. We have a lot of money compared to worldwide standards. All of us wish we had more because you are the recipient of this money. But I think you would find interesting a current program, an ongoing announcement for molecular therapies for eye disease. I'll show you the final slide on that in a moment. Courtesy of Congressman Pete Sessions, who has a family member affected with retinal degeneration. We are putting out a new challenge very soon, by the end of the year, on 3D retina organoids, and some of you may be interested in that. Just then to conclude on the molecular therapies for eye disease, this is an area of particular interest. We want to take the knowledge, or some of the knowledge that has been discovered in basic laboratories, and see if that can be focused on ultimately human therapies at a level of understanding the pathways, understanding the biology, not random therapies or therapy efforts. Perhaps, Bernard, we'd like to move beyond the 1940s also, as all of science wants to control and modify gene delivery, use small molecules, optogenetics. Again, these are ideas that were very much discussed yesterday and today, and the success rates for these have been excellent applications, highly competitive, and the monies are available. And I realize that I'm here in Paris, and you're asking the question, can you get this money? And the answer is yes. there are some requirements, mostly that the Eye Institute has to take care of, but in fact, the monies from the National Eye Institute are available competitively on a worldwide basis. So with that, thank you, Professor Sahel, for a wonderful meeting. I expect that over the next 10 years there will be some pretty remarkable things that we all pay attention to. Thank you.